In this video, I'm going to build a simple API gateway using Spring Cloud Gateway and Spring Webflux. I'll leave the link to this article in the description if you want to dive deeper into it. The main job of the gateway is to route incoming API requests to downstream services, and filters are used for pre-processing. In Spring Cloud Gateway, we use route predicates to match API requests to routes, and filters to process requests before they reach downstream services. We'll use the fully expanded form, so it's easier to spot and fix errors. We begin with route predicate factories. The after route predicate factory takes a zone date-time parameter and matches requests that come in after the specified time. Next, we'll demo it with a UI login endpoint. The configured time is 12:20 a.m., while the current time is 12:42 a.m., so the login page is still accessible. In this video, I won't be demonstrating all the filters. If you have any questions, please leave them in the comments, and I'll review them and make a video explaining them to you. I'm changing the time to 12:45 a.m. and attempting to access this service. Let's see the result. Next is the before route predicate factory. It allows access to the service until the specified time, and then blocks access. The between route predicate factory, on the other hand, allows access only within a specified time range. The configuration for both is similar to the previous demo. The cookie route predicate factory accepts two parameters, a name and a value, where the value is matched using a regular expression. I'll start the demo, and let's see the result together. It's commonly used in scenarios such as user-based request routing, A/B testing, canary releases, feature flags, multi-tenancy, and flexible routing without changing application code. The header route predicate is used in scenarios such as routing based on client type, API version, or feature flags, canary and blue-green deployments, separating internal and external traffic, and controlling request flow without changing the URL. Next, I'll demo this so you can see how it works. The host route predicate factory matches routes based on the value of the HTTP host header. You should use the host predicate for multi-tenant SaaS applications, subdomain-based routing, white label systems, and domain-based APIs. The method route predicate factory routes requests based on the HTTP method. It's commonly used to separate read and write operations, protect APIs, and support canary deployments. The path route predicate factory uses a path matcher to match path patterns and a match trailing /flag, which is true by default. If you set it to false, paths with a trailing slash won't match. The extracted path variables can then be reused in gateway filters. Now, let me demo how it works. The query route predicate factory matches a route if the request contains a specific query parameter value. Now, let me demo how it works. The remote address route predicate factory lets you match routes based on the client's IP address using CIDR notation. For example, a request from 192.168.1.10 would match this route. Dùng khi gateway nằm sau proxy để lấy IP cơ liên thật từ FWAT4. The wait route predicate lets you split traffic proportionally. Each route has a group and a wait, and the gateway distributes requests according to these weights. For example, a route with weight 8 gets roughly 80% of traffic, while a route with weight 2 gets about 20%. This is great for canary releases or A/B testing. The X-forwarded remote address route predicate lets you filter requests by the IPs in the X-forwarded for header. This is useful when your gateway is behind a proxy or load balancer. For example, if you allow 192.168.1.1/24, a request from 192.168.1.10 will match, while others will be blocked. Let's start with filters. Header manipulation filters are very common and let you customize requests and responses. You can add or remove headers, or set them to specific values, both for requests and responses. For example, you want to remove the content language from the response returned to the client. In the Path and Routing Filters section, The filter can rewrite the request path before forwarding it to the downstream service. Here's a demo. When the user accesses /UI/login, the rewrite path filter removes UI and forwards the request downstream to /login. Rate limiting and security filters. Refer to features for limiting traffic and protecting your services, which are extremely important when deploying a product to a production environment. The request rate limiter controls how many requests a service can handle in a certain period. For distributed systems, it's recommended to use the Redis rate limiter. Now, let's look at resilience and error handling filters. The retry filter retries a request if it fails, with configurable retries, backoff, and status codes. The circuit breaker filter uses Resilience 4J to prevent cascading failures and supports fallbacks. Finally, fallback headers adds exception details to headers when forwarding to a fallback URI. Next, I'll demo the circuit breaker, which is an important part of the system. First, we need to import the required dependency. Then, visit resilience4j.readme.io to check the fields that need to be configured. Here's the basic configuration. Auth Service CB is the name of the circuit breaker that will be used for authentication purposes. Sliding window size retrieves the 10 most recent requests. Failure rate threshold is the percentage of failures. If this threshold is exceeded, the circuit breaker will open. Wait duration in open state is the open time of the circuit break. Permitted number of calls in half-open state is the number of requests allowed to be attempted in half-open state. The circuit breaker has three main states: closed, where requests go normally and failures are monitored; open, where requests are blocked and go to fallback; and half_open, where a few requests are allowed to test the backend. It uses a sliding window, either count-based or time-based, to track failures. In short, the circuit breaker helps prevent cascading failures, gradually retries, and recovers automatically. Global filters are applied to all routes in Spring Cloud Gateway. You can also define custom global filters, which will run in order based on their priority. The Gateway Metrics filter is a default filter that collects metrics for every request. These metrics are useful for monitoring, performance tracking, and error detection, and they can be visualized in dashboards like Grafana. All you need is the Spring Boot actuator dependency, and the filter works automatically. You need to add the dependencies Micrometer Registry Prometheus and Spring Boot Starter Actuator to monitor the gateway. Make sure to enable the gateway and Prometheus in read-only mode and expose the endpoints so they can be accessed for monitoring. Now let's open the actuator and check the endpoints that are exposed. There's a special endpoint for Prometheus, which is an open-source monitoring system. It returns all metrics in plain text, so Prometheus can easily pull the data. You can use Prometheus together with Grafana to build dashboards with charts, tables, and other visual metrics. You can also configure alerts when certain metrics go beyond thresholds.